Hello viewers, I am Dr. Mala Das Sharma, retired professor of St. Pius 10th degree and PG College for Women, Hyderabad. Welcome to my channel Chemphilic. In the video number 43, an organic chemistry problem on ascending and descending series of aliphatic hydrocarbon is presented in a bit unconventional way. Identification of the compound associated with the problem, reactions of interconversion processes, reagents required, and the types of the involved reactions are explained in the solution of the problem. So, riddle number 43, which is an organic chemistry problem with solution, and it goes like this. First statement, an organic compound A is the most common liquefied petroleum gas and one of the most versatile sources of energy. It exists as a liquid and as a gas. Its next higher member, which is denoted by X, in the homologous series exists in two interconvertible structural isomeric forms. And those isomeric forms are chain isomers. Now, second statement, A can be transformed to B, which is a very weak acid, by following the given sequence. Number 1, substitution. Number 2, elimination. Number 3, addition. Number 4, double elimination. The third statement, weak acid B can exchange its hydrogen with the metal, say sodium metal. This exchanged product, that is sodium salt of B, can produce the next higher member of B with methyl halide. The higher member C on two steps hydrogenation finally gives the compound X. Now, fourth statement, the reverse transformation, that is X to A, can be achieved through the following series of operations. Number 1, exchange of an atom of X by one chlorine atom and the result is compound P. Second point, loss of hydrogen chloride from compound P and the result is compound Q. Number 3, attachment of full ozone molecule with Q followed by cleavage of the product by water and the result is two molecules of compound R. Fourth point, addition of hydrogen to compound R followed by loss of water and the result is compound S. Fifth point, attachment of two atoms of second member of the halogen family to S followed by removal of 2 moles of hydrogen halide and the result is compound T. Sixth point, sodium derivative of T and methyl halide together give rise to the compound A. Now let's see the questions. First question, identify A, B, C, X, P, Q, R, S and T. All these compounds which are denoted by these alphabets you have to identify. Second question, how the one chain isomer of X can be transformed to other. Third question, show the entire pathway of transformation of A to X and X to A along with the reagents required and the types of the reactions involved. Now, we'll start the solution. So, statement 1. What is given in statement 1? An organic compound A is the most common liquefied petroleum gas and one of the most versatile sources of energy. It exists as a liquid and as a gas. Its next member, Next, higher member X in the homologous series exists in two interconvertible structural isomeric forms, that is chain isomers. So, this higher member X can exist only as chain isomers. That means X is aliphatic saturated hydrocarbon. And there are only two chain isomers. Only two chain isomers for alkane or saturated hydrocarbon is possible for butane, that is N-butane and isobutane. So that is the next higher member. That means A must be the lower member or propane. We know propane is the liquefied petroleum gas and most versatile sources of energy. So, inference. What inference we can draw? Already I told. Compound A may be propane. The next higher member in the homologous series is butane, which can exist in only two chain isomers, N-butane and isobutane. Now, this normal butane, when treated with aluminium chloride and hydrogen chloride, then it is converted to the another chain isomer, that is isobutane. And this is the answer of your second question, or question number 2. Now statement 2. A can be transformed to B, which is a very weak acid, by following the given sequence: substitution, elimination, addition, double elimination. Now we see the inference. So we have seen our compound A is propane, which is saturated hydrocarbon. So saturated hydrocarbon can undergo only substitution reaction. Say here the substitution by halogen atom chlorine. So one of the hydrogen atom of the propane is substituted by chlorine. Then what will be the product? The product is 2-chloropropane. Why not 1-chloropropane? See, the substitution reaction of saturated hydrocarbon proceeds through free radical formation. That is, these are free radical substitution reaction. And primary free radical is less stable than secondary free radical, and secondary free radical is less stable than tertiary free radical. So, when this propane undergoes substitution reaction by free radical mechanism, then there is a possibility of the secondary free radical and this primary free radical. As the secondary free radical is more stable, so the major product will be 2-chloropropane, because here the substitution is by chlorine, so 2-chloropropane. Now, this path of transformation, reagents and nature of reactions, that is our question number 3. So what we have seen that this propane on substitution with chlorine, 2-chloropropane has formed. Okay. Now next one is the, after substitution, next one is the elimination. In the sequence what we have seen. So this alkyl halide, when treated with alcoholic solution of alkali, say potassium hydroxide, beta elimination takes place. That is, this halogen and one hydrogen atom of the beta carbon atom is removed as hydrogen chloride here, and the alkene is formed. Here the alkene is propene. In the sequence, next reaction was addition. Say, we know that these unsaturated hydrocarbons, alkene and alkyne, they easily undergo the addition reaction, because here it is double bonded compound. Double bond consists of one sigma bond and one pi bond. Pi bond is a weak bond, so it easily breaks down and the reagent can be added up with the molecule. Okay. So here it is addition of chlorine to this propene. Then what will be the result? The resultant compound will be 1,2-dichloropropane. Now, this is vicinal dihalide. That means two halogens and halogen atoms are attached to the adjacent carbon atoms. Now, when this dichloro compound, this vicinal dihalide, when it is treated with either alcoholic alkali or sodamide, then once again this elimination reaction takes place, and here 2 times elimination will occur. This chlorine with this beta hydrogen, again this chlorine with this beta hydrogen will be removed as hydrogen chloride, and finally the product will be the propyne or prop-1-ine. That is our compound B. Now statement 3. The weak acid B can exchange its hydrogen with metal, say sodium. This exchange product, that is sodium salt of B, can produce the next higher member of B with methyl halide. The higher member C on 2 steps hydrogenation finally gives the compound X. So our B is a weak acid and it can exchange its hydrogen with metal, say sodium. Now you see, acetylene or any one alkyne, they are weak acid. That means hydrogen atom attached to this triple bonded carbon atom are acidic, can be released as H plus or can be replaced by metal ion. Okay. Why? Because this triple bonded carbon atom is sp hybridized, and sp hybridization means more of S character. If S character is more, then this carbon hydrogen bonded electron pair will be more strongly attracted by this carbon. So this triple bonded carbon atom will become electronegative. So it can attract this bonded electron pair. So hydrogen atom can be released as H plus. Okay. That's why acetylene or any one alkyne are weakly acidic. So when they are acidic, when it is treated with sodamide, then this hydrogen atom can be replaced by metal. Here it will be replaced by sodium ion. So the product will be sodium propionate. Then when this sodium propionate is treated with this alkyl halide, here it is methyl halide because we are going to produce the next higher member. Okay. Next higher member means one more carbon atom will be added up. So therefore it will be treated with the methyl halide. Say it is methyl iodide. Then the product will be this 2-butene. Here in place of sodium ion, methyl group has come. So this is 2-butene. And this is our compound C. Now, this 2-butene, that is triple bonded compound, it undergoes reduction or hydrogenation. Then it forms first, it is converted to alkene. Here it is 2-butene. And 2-butene, once again on reduction, it produces the butane, that is saturated hydrocarbon, which is our X desired product. That is, this is the conversion of propane to butane, lower hydrocarbon, lower alkane to higher alkane. Now statement 4, the reverse transformation, that is X to A, that means higher alkane to lower alkane, can be achieved through the following series of operations. Number 1, exchange of an atom of X by one chlorine atom, and the result is compound P. So our X is butane, so it is saturated hydrocarbon, undergoes substitution reaction. So when it is treated with halogen in presence of light, that is drastic condition, one of this hydrogen will be replaced by this chlorine initially. Now here also, as secondary free radical is more stable and the reaction proceeds through free radical formation, so 2-chlorobutane will form, that is our compound P. Now, second point, loss of hydrogen chloride from compound P, and the result is compound Q. See, now this is alkyl halide. It will undergo this elimination reaction when treated with alcoholic alkali. That means one molecule of hydrogen chloride will be removed and the double bond or another pi bond will be formed. Now this is beta elimination. That means this halogen will take one beta hydrogen atom and will be removed as hydrogen chloride. Now in this case there are two beta hydrogen atoms. This is also beta hydrogen atom. This is also beta hydrogen atom. So if the chlorine takes this hydrogen and removed as hydrogen chloride, in that case result will be 1 butene. And if chlorine is removed as hydrogen chloride by taking this hydrogen, then the product will be 2 butene. In this case, the major product will be 2 butene. Why? Because the elimination reaction is governed by Sedgwick rule. According to Sedgwick rule, if there is a possibility of formation of two products in beta elimination, then major product will be that one which is formed by the removal of the hydrogen from that carbon atom which contains less number of hydrogen. So this is also beta carbon atom, this is also beta carbon atom, but it contains 2 hydrogen, it contains 3 hydrogen. So this carbon atom or this beta carbon atom contains less number of hydrogen. So according to Sedgwick rule, hydrogen will be removed from this beta carbon atom and your product will be this 2-butene, which is our compound Q. Now, part 1. Attachment of full ozone molecule with Q followed by cleavage of the product by water, and the result is 2 molecules of compound R. You see here. Now this alkene, when it is added up with ozone, that means ozone molecule is added up with this alkene and then undergoes hydrolysis reaction. So when the ozone molecule is added up, this is the ozonide. Okay, all 3 atoms of oxygen is added up. After this ozonide formation, it undergoes hydrolysis, that is reacts with water in presence of zinc, that is called ozonolysis. That means it breaks down, this ozonide breaks down. Breaking takes place from here and here, and if it breaks down like this, then the compound will be or product will be acetaldehyde or ethanol. So from this part one ethanol and this part another ethanol. So overall result is formation of 2 molecules of ethanol or acetaldehyde, which is our compound R. Now, fourth part. Addition of hydrogen to compound R followed by loss of water results compound S. Now, R is the ethanol. When aldehydes or ketones or carbonyl compound is reduced by any reducing agent, say here we have taken lithium aluminium hydride, then alcohol is formed. From aldehyde, primary alcohol is formed. So this is acetaldehyde, 2 carbon atoms. So the reduction product is primary alcohol, which is ethanol. And when alcohol is treated with concentrated sulfuric acid at 170 degrees centigrade temperature, then water is eliminated. That is elimination reaction or dehydration reaction, whereby this alkene is formed. So from ethanol, ethene will be formed. That is our compound S. Now fifth point. Attachment of 2 atoms of second member of the halogen family to S, that is to compound S, followed by removal of 2 moles of hydrogen halide, which results compound T. So, our compound S is ethene, which can be added up with any halogen because it easily undergoes addition reaction, unsaturated compound. Then this compound will form, that is 1,2-dichloroethane. Okay, and this 1,2-dichloroethane it will undergo the elimination reaction as usual. We have seen when it is treated with alcoholic alkali. So 2 molecules of hydrogen chloride will be removed and we will get the ethyne, that is our compound T. Now, sixth point. Sodium derivative of the weakly acidic compound T along with methyl halide gives rise to compound B, and hydrogenation of B gives A. So, this is our compound T, which is the ethine. And as usual, as I told you, ethine or acetylene or any one alkyne, this hydrogen atom attached to triple bonded carbon atom are acidic, that means can be replaced by metal ion. So when it is treated with sodamide in liquid ammonia, then the sodium acetylides is formed. And this sodium acetylides, when it reacts with alkyl halide, here we want to prepare the propane, that is 3 carbon atom. So we have to take methyl halide. So when it is treated with methyl halide, then this methyl group is introduced. That means from this acetylene, means from acetylene through the sodium acetylides, you can form the propyne, 3 carbon atoms. Okay, propyne. Now, propyne, there are triple bond, that means 1 sigma bond, 2 pi bonds, which on hydrogenation, that is reduction, first it will form the propene double bonded compound. Once again on reduction, it will form the propane, that is our compound A, which is the saturated hydrocarbon. So, this overall reaction shows the ascending series, that means the lower alkane to higher alkane, and the reverse one, that is descending series, that is higher alkane to lower alkane. So during this overall transformation or in the problems, we have compound A, B, C, X, P, Q, R, S and T. All these compounds are formed, means which are denoted by this alphabet. What are those compounds? This is our question number 1. As we have seen, compound A is propane, compound B is propyne, compound C is 2-butane, X is N-butane, compound P is 2-chlorobutane, Q is 2-butene, R is ethanol, S is ethene and T is ethine. So, this is the solution of this problem and this is the answers of the question number 1. So we have come to the end of this video. Thank you.